All right, so we're going to look at a little preview of what we're going to be doing on Tuesday. It's going to give you a heads up. Hopefully you're watching this sometime over a gorgeous 3-day weekend, just to get your brain thinking about kind of this whole new idea of looking at infinity or adding something up forever to infinity, because this is a good preview of what's really about to happen with sequences and series, which is coming up in a week. Okay, so an improper integral is, I'm going to try and find the area under the curve. That's normal. That's Calc 1. But the whole thing is I'm going to try and find the area under the curve, and we normally say from A to B, or like in this picture here, if I say it from, let's say, 1 to 4. Visually, I can go from 1 to 4, and you should be able to find that area because you see it. You can grab it. You can eat all of that yellow banana. It's right there from 1 to 4. Okay, and that was under, in this example, 1 over x. Okay, but improper is, I don't want to find the area from 1 to 4. I want to find the area from 1 to forever to the right. So 1 to infinity. The idea of improper is this. When you do f of, so like when you integrate stuff, like the integral of 1 over x dx from 1 to infinity. I'm kind of doing it all at once. That's ln of x from 1 to infinity. Here's the part. You can't just say, oh, it's that, because that makes no sense because you just plugged in a concept. Now, normally it's from, like the first example I did when I said it was 1 to 4. You'd be going from 1 to 4, and you could say it's ln of 4 minus ln of 1, and you get a number out of that. But right now I'm getting ln of infinity. Ooh, that feels weird. That feels improper. Oh. And it's kind of weird too. Think about this. That yellow, if it goes forever, you're going to be painting forever and ever and ever. You will never stop painting. Now, you can already see that function goes really close to 0. So way over here, I'm just adding a little bit. I'm just adding a little bit. Look at the bottom right of your video if you're not noticing. I'm just adding a little bit of the blue. So in the end, I'm adding really small specks of paint, but I'm still doing it forever. If you hired me as a contractor to paint that area, it would take me forever to paint it. So if it would take me forever to paint it, wouldn't I need infinite amount of paint? Or maybe not. Wait a second. If I'm going to paint forever, because I will never hit infinity, maybe in 10 days I'm at a billion. Maybe a year later I'm at a trillion. Maybe when James graduates high school, I'm finally at a billion squared and I'm still painting. And I feel like I'm a slave and I feel like I'm in prison. I just keep going. And imagine that way over there. They're just little specks of paint. Like I'd have to zoom in and use my microscope to figure out where I'm adding a little bit more paint, but I would still be doing it. And by the time I die, I'm at a Google. Is that a number? I think that's a number. I'd be at a Google, and I'm still, I'd still be painting. So how in the world can I paint forever and yet only use a certain amount of paint? Or is it always, if I paint forever, I have infinite amount of paint? So this is where we're starting to mesh with infinity, and it's starting to clash with some of our ideas of it. If I paint forever, to me, I should have infinite amount of paint. But maybe I don't. How can I show that? Let's look at some math. Okay. So again, improper, the big reason why is when you plug in, you're doing f of a concept minus f of a number, and somehow I'm trying to get a number out of that. So we're going to just do it for 4 examples. 1 over x squared, 1 over x cubed, and 1 over x to the 4th. They're all on my little Desmos picture there. And we're going to see what we get if we get it. So the first guy, we're going to do the 1 over x. And I want to paint it from 1 all the way over. So I'm going to do, I think I can do it right up here. The integral from 1 to infinity of 1 over x dx. Now, since it's improper, the issue is I don't know how to plug in infinity. Okay, so what they kind of do to avoid this is they change this problem and they say, let's do the limit as, let's call it b. goes to infinity of 1 to the b, that's not a 6, it's a b, of 1 over x dx. So then that's a subtle difference if you're looking at it. It's like, what, does that fix all answers? I'm still going to try and plug in infinity. It's just acknowledging the fact that I'm making b a number that's trying to go forever big. So then I'm going to get the limit as b goes to infinity of ln of x from 1 to b, which, hopping down here, would be the limit as b goes to infinity of ln of b minus ln of 1. Now, stare at that versus this one here, not with the green, but with the blue. Is it basically the same thing I already written? I'm trying to do ln of infinity, and what am I writing here? Basically ln of infinity. It's just saying it as ln of b as b approaches infinity. So instead of just plugging in a concept, I'm plugging in a number that approaches that concept. It's that whole limit idea. Okay. So on this part I can handle. That's 0. So now I know this goes to the limit as b goes to infinity of ln of b. Now, let's look at ln of b. Let's look at ln of x. The ln of x guy looks like this, if you graph it. So as I get super big on the x, as x goes forever to the right, what happens to my function? It goes forever up. So this guy goes to infinity. And this should make sense to us. So the all said and done, there it is, all said and done, 1 over x dx goes to infinity. Meaning, you're going to paint forever, so you're going to have infinite amount of paint. Makes complete sense to me. That's what we kind of talked about before when I was dying and I was still painting out at the Google. I would be needing infinite amount of paint to cover all of that red area. All of that to me makes sense. Okay, it's going to be the next page. It's going to be like, what just happened? So let's do it on this one. We're going to do it all over again with 1 over x squared. Now, look at this. It's obviously below the red part. So if the red went to infinity, the blue has to be something less than infinity. But can that still be infinity? Can you know, back to that playground thing. Oh, I'm infinity. Oh yeah, I'm infinity plus 1. Are those the same? Are they not? But visually, do you agree the blue is underneath the red? So we're going to have to figure out what the blue is worth. We already know the red, and when I keep saying the red is the guy that we just did. So the red area equals infinity. I would need infinite amount of paint to paint the red. Now the question is, what is the blue area? And again, my brain is telling me, if you're painting forever, you need infinite amount of paint. That's what my brain tells me. Paint forever, need infinite amount of paint. Let's take a look. So I really want to do 1 to infinity of 1 over x squared dx. And technically, we can't say that. So we're going to say limit as b goes to infinity of 1 to the b of 1 over x squared dx. The math is pretty simple on the integration part. That gets me negative 1 over x from 1 to b. Again, where the limit of b is going to infinity. And here I'm getting the limit as b goes to infinity of negative 1 over b minus a negative 1 over 1. Now make sure you're okay with that minus the minus part. I can kind of put this in parentheses if you wanted to. It's f of b minus f of a. Well, now it's going to be minus that negative 1 over 1. So in this case, I got limit as b goes to infinity of negative 1 over b plus 1. Now, stare at this part here. As your numbers get really, 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 really big, what's negative 1 over really, 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 really big? That becomes 0 plus 1, which now equals 1. Subtle difference. This red guy, you had to plug in basically infinity to ln and it blew up. This time you got to plug in infinity to negative 1 over x and it disappeared. And now my blue area is 1. This is where your brain starts to go, I don't like this. Or your brain's like, whoa. How long will it take me to paint the red? Until I die plus more. How long would it take me to paint the blue? Until I die plus more. You will never reach the end of either one of the red and the blue. Do you both, all of you agree that way out at Google, at a billion squared, at a billion to the billionth or whatever, way out to the right, you're basically painting just little specks. Like you would need a super duper microscope. It would be smaller than atoms, but you would still be painting little atoms and then little protons and then neutrons and a little electron and then quarks. Maybe, I don't know. But really, 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 really small, you're still painting it. And you're going to paint forever. So which one makes the most sense? The red one, because I'm painting forever, so I probably need infinite amount of paint to cover that forever. But then all of a sudden, you just kind of lower the roof a little bit. And when I mean a little bit, it's a little bit. You can see a difference in the roof. Let me kind of highlight here. I see easily here, I lowered the roof. I pushed the red down through that green to hit the blue. But look way over to the right, and that roof is basically the same roof way out to the right. The big visualness of difference is basically like from 1 to 8, I can see how much I pushed the roof down. That red pushed through the green to land on the blue. What's crazy is that pushing down went from having an infinite amount of paint, pushing down to 1 gallon of paint. You gotta be kidding me. I'm gonna paint forever and I only need 1 gallon of paint. Hey, go to Lowe's. Hey, guys, I'm gonna paint for the rest of my life, but I only need 1 gallon of paint. They'd be like, yeah, right. You're gonna use that up in 4 hours. No, I won't, because it's just a little speck at a time, and somehow this is where we're going in next week, the next month, and the next rest of your life in Calc 2. Somehow I can do it forever and only use 1 gallon. Weird. Just weird. All right, let's try it again. Now we're going to do 1 over x cubed. Okay, so now that's the green guy. Now you got to think through this. Okay, the red was worth infinite amount of paint. The blue was worth 1 gallon of paint. The green, that's what we're trying to find. I do think from blue to green, you're going to have a little bit less issue of understanding this. If my green guy is lower than my blue guy, again, can you see, let me squiggle a little bit here. Can you see this extra space above the green is in that blue category? So if I push my blue category down, if I lower the roof to the green, I get to remove the black. So you should feel okay that the green is going to have to be less than 1 because it's smaller than the blue. The part that you guys don't like is saying the blue had to be less than infinity, and somehow in one little movement, boom, I went from infinity down to 1. What? That's the weird part, red to blue. From blue to green, I think you're going to accept that if I get an answer of like a half or a third or a fourth, that makes kind of sense because it should be less than the blue. Let's try it out. So I'm going to be doing integral from 1 to infinity of 1 over x squared dx. But technically, because I don't want to officially plug in infinity, I'm going to say b goes to infinity of 1 to the b of 1 over x squared dx. And that's going to get me, x to the negative 2, add 1, divide, man, I'm tired. X to the negative 2. I'm going to add 1 to the exponent and divide by it. I'm going to get the limit as b goes to infinity of negative 1 over Oh, I'm not doing x squared. I was like, I just did this problem. Hello. Sorry, guys. 1 over x cubed dx. So let's see, x to the negative 3 goes to x to the negative 2 over negative 2. Okay, negative 1 over 2x squared from 1 to b. Okay, which means this is the limit as b goes to infinity of negative 1 over 2b squared minus, in parentheses, negative 1 over 2. Now we're staring at this portion. And in this case, when b goes to infinity, b squared goes to super big. 2 over super big is super, super, super big. Negative 1 over super big is 0 plus a half, which is a half. So now we said it's got to be less than 1, and we found it. It was a half. Okay? Somehow, if I paint forever red, infinity. Paint forever blue, 1. Paint forever green, a half. And you're getting the idea here that if I do this purple guy, he is less than the green guy. So we got red equals infinity. We got blue equals 1. We got green equals 1/2. And the purple has to be, again, less than the green because it's lower. I lower the roof. And you can do it. Let's see, the integral of 1 to infinity of 1 over x to the 4th dx. Technicality here, b goes to infinity, 1 to the b of 1 over x to the 4th dx. That's the limit as b goes to infinity of negative 1 over 3x cubed from 1 to b. So limit as b goes to infinity of negative 1 over 3b cubed minus negative 1 over 3. You're kind of seeing the pattern here, hopefully. That goes to 0 plus 1/3. You get 1/3. So now the purple is 1/3. Red is what I want to hold on to. I get red. Paint forever should be forever. I don't like how it went from infinity down to 1. But once you told me the blue is worth 1, I'm okay saying the green had to be less than 1. I'm okay saying the purple had to be less than the green. That makes sense to me. But I don't know how it went from one option was infinity to the other options were a gallon of paint, a half gallon of paint, and go paint forever. What? Okay. And summarizing, we did 1 over x got me infinity, 1 over x squared got me 1, 1 over x cubed got me a half, 1 over x to the 4th would have been 1/3, and then that means 1 over x to the n would have gotten me n minus 1. What I mean by that is if I asked you, hey, paint me forever 1 over x to the 10th dx, that you would have already known was 1/9, okay, because of just the patterning of it, okay? Kind of cool. Hopefully you see that pattern, by the way, of how I did it quickly. Let me highlight. 1, 0, 2, 1, 3, 2, 4, 3, n minus 1, 10, 9. Okay? So I have that. It's just weird to me. How can I paint forever and yet get a number? How can I paint forever and get a number? How can I paint forever and get a number? And one way to preview that is I'm going to start with 0.9, and I'm going to add 0.09. I'm going to add 0.009. Now, does that kind of visually somewhat make sense about maybe I'm adding 0.9 worth of paint, and then later I'm going to add a little bit less, 0.09 worth of paint, and then a little bit later I'm going to add a little bit less, 0.009 of paint, and I could keep adding every single day a little bit less paint, a little bit less paint. And if you do this da 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 forever, then you get 0.9999. Silent people, 9999. 9999999. Every day I'm adding a 9 to this. What is 0.999999999 worth? Worth 1. And that's kind of like that 1 gallon of paint that we had on this blue example. Okay. So there is a way just with a number that I showed you where you can add forever, but it doesn't pop out to infinity. It popped out to 1. All of this is just previewing what we're going to be diving into next week on Tuesday, on Wednesday, and then really diving into a lot more with sequences and series. So hopefully that helped you just get a preview of what we're doing next week. Again, 3-day weekend, enjoy it, and I'll see you on Tuesday. Thanks.